Hi and welcome, my name is Lon. In this tutorial, we'll focus on the enumeration data type in C#. Please remember to subscribe, it's free, and can help you reach the next level in programming and technology. If you're already subscribed, please smash the bell icon so as not to miss out on valuable content. Right, an enumeration is a distinct data type and is declared using the enum keyword. I'll mostly refer to the enumeration type as an enum throughout this tutorial. An enum consists of a set of named constants called the enumerator list. Right, let's start by creating a basic example using an enum. So the enumerator list for this enum will consist of the 12 months of the year. You'll notice we are not setting the values for each of the items in the enum. So by default, each item will be given an integer value. The first item, Jan, will by default be set to a value of 0. The subsequent items will be set with values that are sequentially incremented by a value of 1 from top to bottom. Jan will be set to 0, Feb will be set to 1, Mar will be set to 2, and so on. So you can see we have created our enum within the program class. This means that this enum at the moment is only accessible within the program class. So let's say that we wanted this enum to be accessible to the program class as well as potentially other classes that might be created to extend the functionality of this application in the future. So if we cut and paste this enum so that it is now present directly within the namespace rather than just within the program class, the month enum can be accessed from any class that gets created within this namespace. So let's use our new enum within the context of a basic method. Let's create a public static method named processMonthlyExpenditureData. This method will be static so that we are able to directly access the method from within the main method and will not have to instantiate an object from our program class in order to access the processMonthlyExpenditureData method. We must use the void keyword to indicate that this method does not return a value. We want this method to accept one parameter, which will be of the month enum data type that we have just created. Let's create a switch statement within our new method. And you can see that using an enum as the match expression and the enum's enumerator list items as the pattern match candidates in our switch statement is effective in the creation of neat and readable code. For more information on switch statements, please view the 11th part of the C# for Beginners course, which is dedicated to providing content regarding switch statements. For convenience, I've included a link to this tutorial below in the description. Essentially, this function is created for the purpose of centralizing the processing of expenditure data for each month of a particular year. As this tutorial is primarily focused on enums, we'll omit the code for processing data. In its place, we'll simply write a brief message to the console screen. This method will state that the processing of appropriate data for the month passed into the method is being processed. Note that the default switch section throws an exception if an invalid value is passed into this method. All other switch sections are dedicated to running code specific to a particular month of the year. So let's call the processMonthlyExpenditureData method from our main method. Let's pass in the month of January as the parameter to the method, meaning we wish to process data relating to the month of January. Let's run the code. And the result is as expected. The code within the switch section, denoted by the Jan enumerator list item value, is run exclusively. So let's say we wanted to process data for the month of February, August, and December. We can implement the code like this. And this is an expected result. Each time the processMonthlyExpenditureData method is called from the main method, data processing related code is run for the switch section pertaining to the month passed into the method. Let's write the code to output the integer value associated with, let's say, 2 of the months in the enumerator list items. Let's choose Jan and Aug. I've included an explicit data type conversion operation from the month enum to an integer data type to show that an enum is its own data type, but can be easily converted to an integer value where appropriate. There are times where, for example, you may wish to perform mathematical operations that include enum values. You'll need to convert the enum to an appropriate numeric value to enable such operations in C#. Let's run the code. So you can see by default that Jan is representing an integer value of 0. We did not assign a specific value to any of the items in the month enumerator list, so by default values have been set for all of the items. The value of org is 7 because it is the 8th list item in the month enumerator list, and the first item is set by default with an integer constant of 0. What if we wanted the first item in our month enum to be 1 and all the other items to be updated appropriately, i.e. to be incremented by a value of 1? All we need to do to accomplish this is to set the first item Jan explicitly to a value of 1. Let's run the code. This is an expected result. Jan now has a value of 1, and because we have explicitly set the Jan enumerator list item to a value of 1, this change is propagated through to all the other enumerator list items in the month enum. So org is now set to a constant value of 8, which is more intuitive because obviously August is the 8th month of the year. So at present, the integer values set in the enumerator list items in our month enum are all less than 256. So this means we are able to explicitly set our enum items to byte data types. We can stipulate this by implementing a colon after the enum name month, and then we can follow this with the byte data type. Let's run the code. And this is an expected result. So the approved data types for an enum are the following integral types: byte, sbyte, short, ushort, int, uint, long, or ulong. The data type declared for this enum will impact how space is provisioned in memory to store the enum. So let's create a more sophisticated example using the month enum. Let's say a requirement outlined by the boss has come through. The requirement is for a report generating application that must show the total average minimum or maximum expenditure for any combination of months for the relevant year. So let's first remove the colon byte code from our month enum so that the month enum uses the int32 data type by default. We'll now explicitly assign integer values to each of the items in the month enum. So have you noticed the pattern inherent in these values? We are using the base 2 binary numbering system for each of the item values in the month enum like this. The first item is 2 to the power of 0, which is 1. The second item is 2 to the power of 1, which equals to 2. The third item is 2 to the power of 2, which equals to 4. And the fourth item is 2 to the power of 3, which equals to 8, and so on. Let me make this pattern more clear by showing the binary representation of each of these unique values. In binary notation, each of these values looks like this. You'll see later in this tutorial how this allows us to use binary mathematics to pass one or more options of these enum values to a method as one value. You can create a variable of the data type month enum and assign it a value using the AllBitwise operator to indicate that we wish to create one report containing data pertaining to the months of January and May. So here is how the code looks when using an AllBitwise operator to combine two integer values into one value. So Jan followed by the OR operator May results in an integer value of 17. So let's take a look at the binary mathematics involved here. So you can see 1 or 16 in binary equals to 17, and you can see how it's represented in binary. 2 to the power of 0 plus 2 to the power of 4 equals to 17. Don't worry if you don't immediately understand this. This is a beginner's course and is intended to demonstrate how an enum can be useful for creating concise, sophisticated, and at the same time readable code. But if you are so inclined, by all means spend time on this. It is definitely worth knowing, as binary mathematics is fundamental to how a computer works. So let's create the code. First, we want to create a method that populates an array. Each item in the array represents the total expenditure for a particular month. So the array item at index 0 will be the total expenditure for the month of January. The item at index 1 of the array will contain the value representing the total expenditure for the month of February. The array item at index 2 will contain the value representing the total expenditure for the month of March, and so on. We have discussed in previous tutorials that the decimal is the best data type to use to define variables for storing monetary values. This is because of the precision supported by the decimal data type. Accuracy is obviously highly important when creating financial applications, so we are storing the values for each month of a particular year in a decimal-defined array named data. These monetary values are all arbitrary. So January's total expenditure was, let's say, £5,000. February's total expenditure was, let's say, £3,000.50, and so on. And let's say in December there was a company Christmas party, which meant expenditure was a little bit more than in the other months. In the real world, this data would likely come from a database. Note that we have defined an array in the main method to contain 12 decimal values. We are then passing this into our populate monthly expenditure data method. As discussed in earlier tutorials, an array is a reference type. This means that the array object we are instantiating in our main method is the same array that will be populated in our populate monthly expenditure data method. Remember from previous tutorials in this course that a reference type variable stores a pointer to the data and not the data itself. So when the data array is passed into the populate monthly expenditure data method, the array data itself is not passed into the populate monthly expenditure data method, but a pointer to the same data referenced in the main method is passed to the populate monthly expenditure data method. So basically, any changes made to the data array in the populate monthly expenditure data method will be reflected in the data array referenced in the main method. So we want to create a report not for just one month of the year, but for data pertaining to a combination of months. We can apply the OR bitwise operator between a number of month enum list items to do this. This will result in a binary value that denotes a combination of months. So now I'm going to create an algorithm that will count the number of bits set to 1 for the value returned by this bitwise operation. The number of bits set to 1 will correlate to the number of months we have combined. This algorithm is known as Mike Koenig's algorithm, which is very efficient because the number of iterations executed for the while loop in this method will be the same as the number of bits set in the binary number passed to this method. So the method is appropriately named countBits. And the reason for this method is that we want to know the optimal number of elements to define for an array that will be used in a report outputting data related to one or more months of a particular year. So let's create a method that will return a decimal array containing the expenditure data for each of the months we have combined in our bitwise OR operation. Let's name this method getReportData. We include the decimal followed by empty square brackets to denote the decimal array that will be returned by this method. The first parameter passed to this method is a value representing the combination of months we wish to include in the report, and the second parameter is the decimal data array that contains all the monthly expenditure data for the year relevant to this report. So let's define an integer variable named count and initialize its value to 0. This variable will be used as a counter within a for each loop, which will be implemented in this method. Let's define another integer variable. The variable will be assigned the result of a bitwise mathematical operation that will return a value denoting whether a month is suitable to be included in the report, and therefore whether we should retrieve the expenditure for this month to be included in our report. Let's initialize its value to 0. Now we will create another integer variable that will store the value of the number of months that are relevant to this report. We are using Mike Koenig's algorithm to calculate the number of bits set to 1 in a binary representation of the value stored in the month's parameter. So the method that we have created to implement Brian Koenig's algorithm is named countBits. Note that when we pass the month's parameter into the countBits method, we must convert it to an integer. So the countBits method returns the number of items that need to be provisioned for in our report data decimal array, which will store the expenditure data for each month that exists in the month's parameter so that we can use this array to create a report from this data. Let's now define an integer variable named index. This will store the result of a calculation done against the value of each month enum item to be included in the report so that we can retrieve the appropriate item from the data array, which is the array that stores all the expenditure data for a particular year. So let's now implement a for each loop that will iterate through each item in the month enum. Note how we are able to use the enum.getValues static method to return the enumerator list for the month enum as an array. Note there is also an enum.getNames static method that can be implemented to retrieve an array of names for the enumerator list items. It is not necessary to use the enum.getNames method in this application. So the first item representing the month of January will be a value of 1. The second item representing the month of February will be a value of 2. The third item representing the month of March will be a value of 4. The fourth item representing the month of April will be a value of 8, and so on. Within this loop, we first want to assess whether to include a particular month in the report, and then, if we do want to include the month in our report, we must retrieve the appropriate expenditure data from the data array that stores the expenditure data for each month in the relevant year. So in order to see if a month item included in the month's variable value should be included in our report, we'll perform a bitwise operation, and the returned value is assigned to the test month inclusion integer variable. We then test the value of the test month inclusion variable through the implementation of an if statement. The if statement test condition reads like this: if the value stored in the test month inclusion variable is greater than 0, we must include this month in our report. Let me briefly explain how this bitwise operation works. So if the combination of January and March has been passed into this method in the month's parameter, the binary representation or base 2 number system representation of this combination of month enum items will be 101. The decimal representation or base 10 number system representation will be 5. So 2 to the power of 0 plus 2 to the power of 2 equals to 5. But let's look how we can apply the AND bitwise operator for this value against each binary represented value of the month enumerator list to validate the inclusion of the relevant month in our report. So the first item in the month enumerator list has a value of 1. We can represent this value in binary with 3 bits like this, read from right to left, 1, 0, 0. So we test the value in our months variable, which as discussed in binary notation is represented as 1, 0, 1. So let's break down what happens when we apply the bitwise AND operator between the binary number 101 and the binary number 100. Remember, it's read from right to left. So we perform this calculation from right to left. So let's break down this calculation and we'll look at each bit from right to left. So performing the AND operator against the first bit for each of the operands. So the result of 1 and 1 equals to 1. So we already know that the result is greater than 0. But let's finish the calculation. So then we perform the same operation against the second bits for each of our operands. So 0 and 0 will yield the result of 0. Then we do the same operation against the third bits of our operands, the third bit from the right for the value representing the combination of January and March is 1. The third bit from the right representing the month of January, which is the first item in our month enumerator list, is 0. So 1 and 0 equals to 0. So the final result is 1. This value is of course greater than 0, so we include the month of January in our report. So the next value to compare is the month of February. The month of February is set to a decimal value of 2, which represented in binary is 010. So if we look at the bitwise operation 010 and 101, look how none of the bits match. From right to left, 0 and 1 equals to 0, 1 and 0 equals to 0. And we know that 0 and 1 equals to 0, so the final result is 0. This means that the if statement testing the value stored in the test month inclusion integers variable will return false, so we will not include the month of February in our report. The code in the if statement will not be run because the if condition returns false. So for the third iteration testing the month of March, March is represented by an integer value of 4, which represented in binary read from right to left is 001. 001 and 101, so 1 and 0 equals to 0, 0 and 0 equals to 0, 1 and 1 equals to 1. So the final result is 001 in binary, which is an integer value of 4. This value is of course greater than 0, which means we can include the month of March in our report. And this process repeats until we have traversed all the enumerator list items in our month enum. So let's discuss the code within our if statement, i.e. the code that will be executed when the if condition returns true. So let's say the if condition is true, so we now want to implement code to copy the appropriate month's expenditure stored in our data array to our report data array. So to do this, we first need to calculate the index position of where the appropriate expenditure value is stored in our data array. Bear in mind that the values set for the items in our month enum do not correspond in a straightforward way to the index for a month in a year. For example, we have set the month of June with a value of 32, but we can calculate the appropriate index by finding the base 2 log of the appropriate month enum item. We are using C#'s inbuilt math class to perform the log calculation. The log method returns a double, but we want a whole number for the index of the relevant array item, so we can use the math class's round method to round the double value appropriately, and then we must explicitly convert the value returned, which will be of type double, to an integer data type. We have now calculated where the appropriate month's data can be found in the data array, so we can then simply copy the appropriate value to the report data array. Once we have done this, we need to increment the index pointer for our report data array by applying the ++ unary operator to the count variable. Once all the elements in the month enum have been traversed and the loop is exited, we can use the return statement to return the report data decimal array to the calling method, which in this case is our main method. So let's create the final method for this application that will output a report based on the data in the report data array to the console screen. So before we create this method, let's create another enum. We'll call this enum report type. So the types of reports we wish to create are sum, denoting a report revealing the total expenditure for a group of months; average, denoting a report revealing the average expenditure for a group of months; min, denoting a report revealing the month with the lowest expenditure when comparing the expenditure for each month in a group of months; max, denoting a report revealing the month with the highest expenditure when comparing the expenditure for each month in a group of months. So let's create the method that will output the report to the console screen. We'll call this method outputReport. This method does not return a value, so we can indicate this by using the void keyword. This method will accept 3 parameters: The first parameter will be the report type enum. We'll implement a switch statement to run a particular report based on the report type enum value passed to this method. Each switch section will represent a type of report, and each of these reports correlates with one of the items in the report type enum. The second parameter will be a value containing a group of months of relevance to the report created in this method. The third parameter will accept the report data array. This is the data that will be acted upon to produce a particular type of report. So let's create the structure of our switch statement. Let's then implement code to create the first report, which will add all the expenditure values together and output a brief narrative, which will include this value. So I want to use the sum method on the report data array to output this calculated value. But it doesn't seem to be available. Right, we can easily fix this within Visual Studio by hovering the mouse pointer over the red squiggly lines under the word sum and choosing the pop-up item, show potential fixes, then choosing the next pop-up item, using system.link. The red squiggly lines have now disappeared, and let's confirm the reason for this by navigating to the top of our code. You can see that Visual Studio has added the using system.link directive, which provides us with a useful selection of extension methods, which will now be available to our array. Extension methods are beyond the scope of this tutorial and will be discussed in an upcoming tutorial. For now, all we need to know is that we are able to call the sum method on our report data array, which will sum up the decimal values contained within the report data array. So let's then implement functionality for our other switch sections. And we'll use the average, min, and max extension methods to output the appropriate data in the corresponding switch sections. The default switch section throws an exception. This code will be called if an invalid report type item value is passed into this method. So let's call the output report method from our main method. So we are going to output a report that will show us the total expenditure for a group of months: January, June, December, and July. Total expenditure for months 2145 is £20,000 and 20 pence. So the value of £20,000 and 20 pence looks correct, but what about the value of 2145? That value does not make much sense. Okay, so what is happening is that the value of the included months variable is the integer value, which is the result of the bitwise operation that uses the OR operator to combine the months of January, June, December, and July. The intended value we wanted here was the names of the enum items delimited by commas. So we can achieve this by simply decorating our month's enum with the flags attribute like this. Attributes will be discussed in an upcoming tutorial. And now the report narrative makes more sense. Total expenditure for months Jan, Jun, Jul, Dec is £20,000 and 20 pence. So let's also run the other reports by calling the output report for each of the report type enumerator list items. Great. Let's try a different combination of months and run the code. Excellent. All code examples can be downloaded from GitHub. Please see below in the description under the GitHub code section for details of where you can download the code created in this tutorial. Please subscribe, it's free and can help you get to the next level in programming and technology. If you're already subscribed, please smash the bell icon so as not to miss out on valuable content. Please feel free to engage with me in the comments section. Thank you and take care.